Okay, so now that we're working with the triangles and the measurements of triangles, um, we've started to work with the idea of the three angles inside of a triangle will always add up to 180 degrees. So we're going to start off with that. And then if we're going to talk about the angles inside a triangle, we're also going to talk about some of the angles outside of a triangle, or interior versus exterior angles of a triangle. So let's start off there. Um, you know, we've already been working with this. The three interior angles of a triangle always add up to 180 degrees. Now, that's just called the angle sum theorem of a triangle. But again, it's something that we've already been working on, and we'll just kind of tie it into what we're discussing here. So we're asked to find the missing angle, or the angles of the triangle. So let's see what we have going on here, and I'm just going to blow this up. So in our first question, we're looking for that missing angle. And we've actually seen this question before. The three angles have to add up to 180. So we have x plus 30 plus 55 equals 180 degrees. So of course, we're just going to do a little bit of algebra work here. And x equals 95. So this missing angle here is 95 degrees, making it an obtuse scalene triangle. Looking at number 2 here, we have an isosceles triangle. Now remember from our knowledge about triangles, if we have two legs that are congruent, we also have two angles that are congruent. So we should know that these base angles are congruent, which means if I put an x for one of them, I'm going to put an x for both of them. Remember, if we know two angles are congruent, we could potentially set them equal to each other, or whatever we put for one, we copy for the other. So one of them's x, that means the other one is x. And again, we're doing the same exact work. X plus 40 equals 180. So 2x plus 40 is 180. 2x equals 140, and x equals 70. So each of these are 70 degrees. Again, in an isosceles triangle, we have two legs that are congruent, and we have the two base angles that are congruent. So here we have an acute isosceles. In our third question, we're given algebra for all three angles, but we're doing the same exact thing. We're adding the three angles to 180. So we have three angles here. We're going to add them all up. So I have 3x plus 4. So that's my first angle. My next angle is 4x plus 8. And obviously, it does not matter what order these go in. I just want to make sure that I included all three angles. So I'm being careful to identify them and then make sure that I wrote them into my work. And of course, at this point, we're just going to do some algebra. So 3x, 4x, and 2x is 9x. Our constants, we have a 4 and 8, which is 12, and 6. So 18, 180. Let's subtract the 18, giving us 162. And then we're going to divide that 162 by the 9 and get x equals 18. And again, since we were asked to find the measurement of the angles, we're just going to plug that 18 back in to all three angles and get real numbers. So we can, start wherever you want. I'm going to do 2 times 18 plus 6, and I get 42 degrees. 4 times 18 plus 8, and I got 80 degrees. 3 times 18 plus 4 for 58 degrees. Now my check is 58 plus 80 plus 42 Does that equal 180? And that's going to tell me whether I got it right or wrong. So everything here works out. So we know we have the correct three measurements for those angles. And then, of course, we can say this thing is an acute scalene if we were asked. So we're working with the interior angles of a triangle. Well, we've also got a rule for the exterior angle. So interior versus exterior. Now, an exterior angle, if you look at any one of those angles shaded in blue, the exterior angle is created by extending one side of the triangle. So let's look at a simpler picture here. We have a triangle. An exterior angle is created by taking one side of the triangle and just extending it. So here's our exterior angle right here. That's our exterior angle. And the rule here says that the exterior angle equals the sum of the remote interior angles. Now think about some vocabulary. Adjacent means next to. Remote means over there. So look at the parts that we're using. The exterior angle and the remote interior angles. Now this is a shortcut rule. We certainly could have subtracted from 180 to get into the triangle and then figure stuff out. But it comes in very handy. The exterior angle equals the sum of the remote interior angles. So in this case, angle 1 would be angle A plus angle B. So let's look at a few problems. Now, we'll use number 1 as a good example. I'll show you that there's two ways to do it. If I did not know this rule, then what I would do is I would find y first. So let's call it the old way. 50 plus 75 plus y equals 180. And we find out that y, let's see, 180 minus is 55. And now step 2, these are a linear pair. So 55 plus x equals 180. And I find out that x is 125. And that's a perfectly acceptable way to do it. However, with our new rule, we'll call it the new way, we're just going to say the exterior angle x equals the 50 plus the 75, and we get it in one step. It's the same numbers being used. It's a shortcut and it saves us a step. In some cases, it saves us a lot of confusing work, but it is still just a shortcut. And again, looking at number 2, our rule just says the x, whoops, sorry about that. It keeps happening to me. The exterior angle equals the sum of the remote interior angles. So 135 equals x plus 45. And in this case, x is 90. That's the whole rule. Let's keep going. The exterior angle equals the sum of the remote interior angles. 147 equals 3x plus 12 plus 6x, the two remote interior angles. And we just do some algebra. 9x plus 12. So we're going to subtract 135. And we're going to divide by 9. And we get 15. Now, we could plug it in. We could figure out all the angles, exact measurements. We can even find out angle ACB because it's a linear pair with the 147. So we can do whatever we're asked to do. This is just another rule or a shortcut that helps us do it. I'm going to scroll a little bit so we can do number 4 here. So number 4, again, the exterior angle equals the sum of the remote interior angles. So we have 10x plus 9 equals 7x plus 1 plus 38. And do your algebra, whatever is required now. So we're going to subtract, and I get 3x. I'm going to add for 48, and x equals 16. And again, I can plug it in and do whatever I have to after that. So we have the exterior angle rule. And now we have what's called the third angle theorem. The third angle theorem gets us to where we start to compare two triangles, right? So now we're talking about the angles of both triangles. And all this says is that if two angles are the same, then the third ones have to be the same. So think about if we're comparing two triangles. We know that they have to add up to 180 in both cases. So if we said, okay, well, this is 90 and this one's 30, and 90 and 30. So if two angles of a triangle are congruent to two angles of another triangle, 90 and 30 from triangle 1 are congruent to 90 and 30 from triangle 2. Well, then it really should make sense that the third angles have to be congruent. It's the only way to get to 180 in both cases. Our missing angle in both questions is 60 in both triangles. So the third angle theorem just says, if I have two triangles and two of the angles match, the third ones have to match. That's all it's telling us. So let's put everything that we just did into a practice problem. And all we're asked to do here is find all of our missing angles. Angle 1, angle 2, 3, 4, 5, and 6. Now, if you look at the picture, there's a bunch of triangles. Pick whatever triangle you are able to work with. Pick whatever triangle you know. Do whatever you can, and then fill in the numbers and move to something else. And again, do whatever you can. The first thing I noticed is that I have a triangle right here. And I already know two of the angles, 20 and 40. So that was a good place for me to start. Now, everybody's different, but that's what I saw first. Start with the part of the picture that you know the most information about. It doesn't have to be angle 1 comes first. So in this little triangle, I know 20 and 40 and angle 4. So 20 degrees plus 40 degrees plus angle 4 has to total 180. And I already know that angle 4 is 120 degrees. All I need is a way or a place to get started. So I'm going to go ahead and fill that in, 120 degrees. And now look at what's going on. We have vertical angles. So angle 2 is 120 degrees. We have linear pairs. For example, angle 1 and 2 are a linear pair. So angle 1 is 60 degrees, and angle 3 is 60 degrees. So that intersection comes very quickly once you find one of them. And we're already almost done with the problem. Now, there's more than one way to do things. That's the way I saw it. Let's figure out other stuff. Again, I'm going to look for a triangle that I know some information about. So check out this big triangle right here. We know the 60 and we know this 90. So 90 plus 60 plus angle 5 equals 180. And angle 5 is 30 degrees. So I can go ahead and fill it in. The only thing left is angle 6. Now look at that little triangle. I'm going to trace that little triangle in red. We know the 60 and we know the 90. Well, wait, we know the 60 and we know the 90. We could do the work, but aren't we going to get the exact same answer? 30. So this is an example of the third angle theorem being used. If I knew the big triangle was 90, 60, x, and the little triangle is also 90, 60, x, those missing angles have to be the same. Or we can do the exact same work. 90 plus 60 plus angle 6 equals 180. And we get the same exact 30 degrees. So which rule we use, when and how we use it, some of them are just shortcuts. Look at this picture here. That was a 60. If you look at this example, I'm going to use purple to show it to you. This angle 2 is the exterior angle for that big purple triangle. Well, 120 equals the 90 plus the 30. So we have the exterior angle theorem being used. I didn't use it, but I could have. So this comes down to knowing the rules so that you can apply them the way you see the problem. Problem solving, right? We're applying the vocabulary and the rules, but we might see the problem slightly differently. As long as we come up with the same correct result, that's absolutely fine. But it takes a little practice and it requires knowing the vocabulary and the rules. Okay. All right, we're going to stop it there and we will pick up with our next lesson.